Section 8.3, we're looking at proving triangles similar by side, 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 and side angle side. Our essential questions: what are two ways to use corresponding sides of two triangles to show that the triangles are similar? So our first side, side, side similarity theorem: if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So in the example, here, AB would match with RS, BC would match with ST, and CA would match with TR. So if those ratios are equal, then our two triangles are similar. So I would know triangle ABC is similar to triangle RST. So example 1 is asking us to see which triangles are similar. So if you want to check all three sides when you're doing this, but if you see two sides that aren't going to work, then that's a good place to start instead of checking all of them. Also, you want to make sure you're matching up smallest to smallest, middle to middle, and largest to largest, unless they give you a specific order to go in. So when I'm looking here, I'm comparing ABC to DEF. So 8 to 4. And then 9 to 6. 8 to 4 we know reduces to 1/2. Whereas 9 to 6 is clearly not going to be 1/2. So those are not equal. So ABC is not similar to DEF. And when we're coming over here, 8 would match with 16. 9 would match with 18. And 12 would match to 24. Okay, and they reduce to 1/2. So then I know triangle ABC is similar to triangle. Then watch how you match it up. Here they give us this, so we would like it to be the same, but double check it. GH is what matches with AB. HJ matches with BC, so we're good. GHJ. Okay. And braid's clearly not working here. This is going back to our previous proportions. It's not 1/2, it's 2 to 1. Alright, but still 9 to 6 is not going to reduce to that. Then example 2 is using the same concept, but they're telling us it's similar. So we know the sides have to match. And this is similar to the stuff we have been doing. So the first thing you want to find here is something where you have two sides that are both numbers. So AC matches with DF, they both have X's. AB matches with DE, they have X's. The 4 and the 10 match. So I have 4 over 10. That gives me a scale factor of 2 to 5. So that is then what I'm going to use in my ratio. You can actually do either one here with the other ones. You want the numbers because then I'm not worried about cross multiplying and having the x's and having an x squared and having to deal with a mess of a problem. But once I'm here, I have the 2 to 5, right? The 4 is in this triangle, so ABC should be on top. So I can do x minus 3 over 20, or I could do 2 over 5 equals 10 over 2x plus 3. using these two. Both things will get me the same result for x. So here, cross multiply, get 40. Make sure I distribute. I get 5x minus 15. Add the 15 to both sides. I get 55 equals 5x. So x is 11. That is my answer. Just to show the other one, and cross multiply, so 5 times 10 is 50. I have 4x plus 6 when I distribute. Add 6 to, or subtract 6 from both sides. I have 44 equals 4x. So that will also get me x is equal to 11. Our other theorem is the side angle side similarity theorem, which says that if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. So here I have x congruent to m. So if zx and pm are equal to zxy over mn, then the triangles are similar. So example 3, determine whether the two triangles are similar. If they are, write a similarity statement and find the scale factor, triangle B to triangle A. So we're looking for a similarity statement and a scale factor if they're congruent. Make sure you note triangle B to triangle A. That means triangle B has to be on top when we're doing our scale factor. So I have the 90-degree angles, so my angles are good. We have 6 and 10 here, we have 9 and 15 there. So 6 over 9, 10 over 15. Both of those will reduce to 2 over 3. Taking a 3 out of here, taking a 5 out of here, we get 2 over 3. So this is my scale factor, and my sides are proportional. So I can write my similarity statement. So my similarity statement would be triangle DEF similar to triangle WYX. And I start just DEF, I named to start with, and then DE, the 9, matches with WY, EF matches with YX. So that is how I got my similarity statement. Then we have the concept summary. This is taken from our book. So basically we have 3 ways to prove triangles similar: angle, angle, side, 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 and side, angle, side. So when I'm looking at shapes, I can determine which one I want to use. So example 4 doesn't tell us what to use. It says tell what theorem can be used to prove that the triangles are similar. So what you want to look at there is what are they giving me. Okay. If I look here, I have 2 sides in both triangles. Finding a third side is hard normally. So side, side, side is probably not a good option there. They're not giving me any angles, though we can find one, which we'll talk about in a second. But they're not giving us any angle, so angle, angle is probably a bad one. So we probably want to go with side, angle, side. So look at how your sides match up. You could have this, these are vertical angles, right? That is one thing that we can mark. So we know angle PRQ is congruent to angle SRT by vertical angles. Okay. And then for our side, sometimes depending on the shape, sometimes these match up, sometimes these match up. What you want to look at is the size. 9 and 12 are the smallest, so those are the ones that should match up. So I have 9 to 12, we have 18 to 24. And both of those reduce to 3 to 4. So then we have shown by side angle side that these triangles are similar.